The next ones, we are doing normal approximation to a binomial, which means two things. And it tells us that the mean is found by taking n times p, and that the standard deviation is found by taking n times p times 1 minus p. Now, the other thing you need is a table that you have. So if you can find your guided reading and find section 6.4. So find chapter 6 guided reading. From your big binder. And in section 6.4, you're going to have a table that you're going to have to consult. Or you can write it all down on your paper, but 6.4, keep going. There it is, that table right down there at the bottom. It's almost to the very end of your packet. It says something like, if p of x equals a, then you have to do negative 0.5 is less than x, which is less than a plus 0.5. If p is greater than or equal to a, you have to do a minus 0.5. Finding that table. Chapter 6. That's what we're doing now. Chapter 6. It'll be almost to the very end of your packet. Alright, so that's 6.1. Let's have to be closer to the end. There's 6.4. That table right there is the one you need. You don't have your table with you. So, it says here, a researcher believes that about 71% of the seeds planted with the aid of a new chemical fertilizer will germinate. He chooses a random sample of 165 seeds and plants them with the aid of the fertilizer. Assuming his belief to be true, approximate the probability that more than 116 of the 165 seeds will germinate. Use the normal approximation to the binomial with a correction for continuity. That's what that table is for, the correction. You either have to add 0.5 or subtract 0.5, depending on if it's a greater or a less or whatever's in the table there. First thing we're going to do is find our mean by taking n, which is the number of the sample, 165, times the p, which is your percent. So if I take 165 times 71%, I get 117.15, yep. Then we're going to find the standard deviation using our formula for standard deviation. So 165 times the 71% times 1 minus 71%. So if I have 71% and I take 100 minus that, I would get 29%, right? So 0.29. I'm going to just write 1 minus 0.71 so you know where I got that number from. So square root of 165 times 0.71 times 0.29. There's your square root, yep. So 165 times 0.71 times 0.29 equals 5.8 something or other. In fact, when I did my calculation, I did that in my later. 5.58287. So, oh, 5 point. Yep, I can read my own writing. 5.8287. In fact, I didn't even do that. I just put it in the formula when I typed it in. So, what we have to do is our correction. We want to find more than 116. So I want to do greater than 116. So in the table from your notes, if you're going to do a greater than, you have to add 0.5 to it, right? See where that is? Mm-hmm. So I'm going to do 116 plus 0.5. 116.5 is going to be my x value. Okay? So when we do this, since we are doing a greater than, we're going to do 1 minus p of z is less than, and then I have my weird formula. Here's my mean, or my sample, 116.5 minus my mean, 117.15 over my standard deviation. And in fact, I think I was getting rounding things, so when I typed it in on the Alex calculator, I just used the whole thing instead of finding my number and rounding it off. So again, if it's a greater than, you have to do 1 minus the less, because on the calculator it does the less. Times the 0.17, or 0.71, I mean, excuse me, 0.71 times the 0.29. All right, so on there you're going to clear that. You're going to do 1 minus the p of z is less than, yep. And then you're going to have on the top,
like that.
Trying to figure out if we need to put some parentheses so that we get the top number right. So let's do, it's 116.5 minus the 117.15.
So this one's wrong?
Oh, yep. That was this number here. 16.5. Yep. Minus the 117.15. And try seeing if you can highlight just this part right here. Yep, up there. Yep, all the way to this. Okay. Ooh. Just right there. Okay. And then do your dividing. There, now then you don't have to figure that number separately. And then on the bottom, the square root of, so your square root of your 165 times your 0.71 times your 0.29. And hit equals. Yeah, there's what I got. So when you put this in on the Alex calculator, if you highlight this before you hit the dividing, then it'll put the fraction under the whole thing. Otherwise, you would want to figure this top number out first before you punch it in. And we came up with where are we rounding? 3 decimal places. So 0.544. 544, yep. 0.544. So again, if this is a greater than, you're going to do 1 minus this calculation. And it's the formula we used before, x minus the mean over the standard deviation. But it tells us not to do any intermediate steps. And that's why I think I was getting rounding errors, and I started to just put the whole thing in, and then I came up with the right answers. All right. So, number 5, in a certain city of several million people, 5.8% of adults are unemployed. If a random sample of 260 adults in the city is selected, approximate the probability that at most, there's that at most then, 18 in the sample are unemployed. So at most means I'm going to do less than or equal to my 18. So if you look at your table for less than or equal to, should I add 0.5 or subtract 0.5? Add, okay? So we're going to use 18.5 for our x value then. So first of all, I'm going to find my mean. My mean, I'm going to take n times p. So n is 260 adults. P, my 0.058%. If I calculate my mean, I would get
15.08.
15.08. I'm not going to worry about the standard deviation because we're just going to plug it in as one big value. Now this one is a less than, so we don't need the 1 minus. We're just going to do the P of Z is less than or equal to, and then our formula. So the X value is 18.5 minus the mean value, which is the 15.08, over our standard deviation, which was our N times P times the 1 minus P. So N was 260, P is 0.058, and I'd want to find out what 1 minus 0.058 is, right? If you do 1 minus 0.058 before we try to plug all that into our calculator, what do we get? Point what? 942. 0.942. All right. That's what we want to have when we punch it into the Alex calculator then.
That 1 minus is there?
Uh-huh. Here we have to do 1 minus P for our formula and our standard deviation. So we did 1 minus our 0.058, which gave us 0.942. So then on our bottom formula, we took N times P times that 1 minus P value. Trying to make it the easiest to type in without having to round. So we're just going to start with the P of Z. We don't have to do 1 minus on this one.
Awesome.
Because it's a less, not a greater. Okay, and then we're going to do our top 18.5 minus 15.08. We're going to highlight that and then do the dividing. And underneath we'll do our square root. So our square root of 260 times the 0.058 times our 0.942 equals. And so to 3 decimal places, our answer is going to be
0.818.
0.818, yep. Okay, so if it's a greater than, we do 1 minus that. If it's a less than, we just use the P is less than or equal to. Number 6 then. A brokerage survey reports that 38% of all individual investors have used a discount broker, one that does not charge a full commission. If a random sample of 70 individual investors is taken, approximate the probability that fewer than 23 have used a discount broker. Fewer than 23 would be less than 23, right? So then we want to look at that little table. If we have a less than, do we want to use a plus or a minus 0.5? We had to do minus 0.5, which would give us 21.5 for our x value then, right? Whoops, that was 23. I changed my numbers. 23 minus 0.5 would be 22.5. How about I use the right number? Okay. So this one is doing a less. First of all, we probably want to find our mean. Our mean is going to be found by doing what? The number from our sample was 70, right? 70 individuals surveyed. That's our N. Our P is our percent. 38%, right? So 70 times that 38% would give us 26.6. I'm also just going to have you calculate 1 minus that 0.38 right away too, since we have to put that in the bottom on our square root. 1 minus 0.38 gives me 0.62, you said?
Yeah.
0.62. 62%. All right. So this one we were doing a less. So since we're doing a less, we just start with the P of Z is less than or equal to. Don't need the 1 minus since it's a less. My X value is the 22.5 minus my mean, which we got 20, oh, it was supposed to be, that was supposed to be 26.6, I believe. Did I just write it down wrong? 26.6. My mean was 26.6. And then my standard deviation, I'm going to take 70 times 0.38 times my 0.62. And round to 3 decimal places.
1649, is that wrong?
So clear that out for me. Let me see what you punched in. So P of Z. Yep. And then on the top, 22.5 minus 26.6. And then you highlighted that and divided it by the square root of 70 times 0.38 times 0.62. There, that looks better. And we got for our answer
0.156.
0.156. All right. The next one.